Well, there's a whole suite of ways that we can study the sun. I myself work with a mission called Stereo, which is two spacecraft, one drifting ahead of the Earth, one lagging behind the Earth in its orbit. And from those positions, we've been able to make 3D movies of the solar surface. And now the spacecraft has drifted apart a little bit further than that, we can image the whole sun. So we're learning an awful lot about our nearest star.
And is it just visual information, or what kind of measurements are you taking?
Well, the cameras that I work with image the solar wind in white light. So it's the sort of light that our eyes are designed to see. But they're very cleverly designed to image some very faint clouds, these mass ejections that are coming off the sun. And with our cameras, we can track these through space with the sun just outside the field of view. And they're something like 100 million times fainter than the sun. But the sun's only just outside, so any photographers would realise that's a very challenging image to take.
And they're impressive things to look at, but why study them, these coronal mass ejections?
Well, a mass ejection represents an immense amount of energy. If you could take all the energy in a mass ejection, it's something like 100 times the world's nuclear arsenal. Or if you're not quite so a megalomaniac about these things, it's the energy in a Mars bar if that Mars bar were 2,000 kilometres long. So it's an immense amount of energy. So we really care about that amount of energy if it's arriving at Earth, because it can have consequences for our technological systems.
Yeah, how might it affect some of the technology that we have?
Well, the most obvious impact that you could see is that these energetic particles could upset the electronics in spacecraft and satellites we have around the Earth. And we have seen that happen on a number of occasions. When the sun's particularly active, it has an 11-year activity cycle, and when the sun's particularly active, we see what are known as single event upsets much more often in spacecraft electronics. But it can also deflect the Earth's magnetic field, it can set up currents in the Earth's atmosphere, and that generates currents to flow in the Earth's surface, and that can cause power surges along cables and any kind of power network we have. So it's not just things in space that are vulnerable, the ground-based technologies are vulnerable too.
Will studying the sun and its sort of solar ejections and the solar weather, will that make us able to better protect our technologies against the solar wind?
Well, there's two ways you can try and deal with solar weather, and that is you can build spacecraft that are stronger and more reliable and more resilient to the sorts of things that come along. But in order to do that, you need to understand what the extreme cases are. So you need to monitor these things anyway. What myself and my group are doing with the NASA Stereo mission is that we're actually looking to see if we can better predict the arrival of these things at Earth. With cameras standing away from the Sun-Earth line, we can actually look back and see this material coming towards the Earth, and we're trying to better predict the arrival of these things at Earth. If you think of it as an equivalent to the weather forecast on Earth, we're probably about where we were in the 1950s for terrestrial weather. We know that these things happen, we know what the consequences can be, but we're trying to work out the best way of measuring them so that we can have a reliable forecast for these things.
And then if you're able to forecast them, is it kind of like a tornado warning? We kind of say, right, okay, this is coming, put up your technological defences.
Yes, very much so. We can see when one of these mass ejections has been launched from the sun. We can estimate what direction it's going in and what speed it's going, and that gives us some rough estimate. And we'd issue at that stage an amber alert. We'd say something's heading towards our planet. But it's not until the storm goes past the outermost of our satellite defences that we can actually see what the magnetic field inside that cloud is doing. And that tells us how efficiently it will interact with the Earth's magnetic field, and therefore what the consequences will be at Earth.
You're working on a project called Stereo. What does that actually involve?
Well, the Stereo mission is collecting a lot of data. It's been in space now since 2006. And we are struggling to analyse that in the sort of detail that we would like to. We've developed techniques. We can look at one or two events and understand those in detail, but we need help. And we teamed up with the Royal Observatory in Greenwich and the team behind Galaxy Zoo to bring a web-based project where we serve our images and our movies, our data to the general public, and they do our data analysis for us, and it's fantastic. I've got 20,000 really interested and excitable research assistants, and it's not many scientists that can say that. So they're gradually working their way through the data set, and we're actually being able to analyse our data in much more detail than we would have been able to do on our own. And in addition to that, they're able to actually use the data in real time to try and produce some genuine predictions of these space weather events and see if there's anything heading towards the Earth.
It's a new wave of crowdsourcing, a way of analysing your data, I suppose.
Well, that's the benefit for us, is that we get to have our data analysed in much more detail. And there are other benefits too. So obviously people have a much closer interaction with the science. They get to understand the science a bit better. And what's nice about it is because it's such an open analysis, for subjects such as climate change, which are quite contentious, if you've got crowdsourcing involved in those sorts of subjects too, then people can see how the data is processed, they can see the sort of science that's going on, and it really is positive all round, a sort of engagement with people about your science.